The host-to-host packet delivery process is extremely important to understand because it's what happens to our packets as they move from one local area network to another local area network. So for example, we have PC1 here who is going to send data over to PC2. And as a result of that, there has to be a way to get that data from one local area network to another local area network. So how do I know that I have two different local area networks? Well, there's many ways to identify that. For example, we can analyze the IP addressing here. If you look at the IP addressing, we have 192.168.3.1 and 3.2 and 4.1 and 4.2. Well, 192 is a Class C address. So it's a Class C address. And the default subnet mask for a Class C address is /24. So if we were using the default subnet mask of /24 here, we would have two different local area networks, two different subnets. Now, why is that? Because if we take this value of 24 and we use our block size technique of 256, subtract from that 255 in the third octet of a /24, then we end up with a value of 1. So in this case, /24, we have 255.255.255.0. That's where I got this 255 from, the third octet. That's where I'm going to find the very last one in binary. So doing the subtraction here, we get a value of 1. So what this means is I'm counting by 1 in the third octet. So I'm counting by 1 in the third octet. What do we have for IP addresses here as the third octet? 3. And then over here, we have a value of 4. Well, 3 would be in one subnet. So we'd have 192.168.0.0/24, then 1.0/24, and then 2.0/24, and then 3.0/24, and then 4.0/24, and then 5.0/24. You see what I'm doing? I'm just increasing by 1 in the third octet. So 3 is one subnet, and 4 ends up being another subnet. So we definitely have two different local area networks here, two different subnets. But also, there's another way to identify it. And the other way to identify it is just realize that, hey, I have a router here. And this router has an interface here and an interface here. Is a router allowed to have two interfaces in the same local area network? Think about that. Can a router have two interfaces in the same local area network? No, it can't. It can't. It'll yell at you if you try to do it. It'll say, this IP address overlaps with the IP address of this interface over here. So IP addressing networks must be unique on your router interfaces. So I know just by looking at this router, I have two router interfaces. I have two different local area networks, meaning I have two completely different subnets. So in this case, anytime PC1 wants to talk to PC2, that router is going to have to take those packets and route them to another local area network. We can see our layer 3 addressing here. So our PC1 has 3.1, 3.2 for the router interface of gig 00. We have 4.1 for the gig 01 interface of the router, and PC2 has 4.2. Look at the layer 2 MAC addresses. We have the layer 2 MAC address for PC1 right here. The layer 2 MAC address for our router interface. The layer 2 MAC address for this router interface. And then we have our layer 2 MAC address for PC number 2. So let's walk through this process together here. So PC1 says, hey, I have some data I want to send over to 192.168.4.2. Now, how did PC1 figure out that IP address? How did it figure it out? Would we typically know the IP address of the device we're trying to talk to? In most cases, we don't. In the real world, we typically know devices by name or by URL. For example, if you wanted to reach Cisco's web server, you would type in www.cisco.com. But then the PC has to figure out what is the IP address of www.cisco.com? Just like in this case, let's say the name of PC2 was really PC2. Well, then the PC says, I need the IP address of PC2. Now, what is responsible for getting that IP address of www.cisco.com or PC2? What's responsible for that? That's right, DNS. DNS will take care of that for us. So we'd have a name resolution process that would take place. I send out a request asking, hey, what is the IP address of PC2? And I got it back as 192.168.4.2. So that's how I learned that the IP address is 192.168.4.2. Or I typed in my application 192.168.4.2. One or the other happened, but more than likely DNS resolved the name for me and gave me that IP address. In this example here, we're going to use UDP for this communication. So now we need to go down through the OSI model. We have our application layer, our presentation layer, our session layer, and for the TCP/IP stack, that's all part of the exact same application layer.